Tintal effect can be observed when sunlight passes through the canopy of a dense forest. In the forest, mist contains tiny droplets of water which act as particles of colloid dispersed in air. Properties of a colloid. A colloid is a heterogeneous mixture. The size of the particles of colloid, it ranges between 10 to the power of minus 7 cm and 10 to the power of minus 5 cm. That is, it is too small to be individually seen by naked eyes. Colloids are big enough to scatter a beam of light passing through it and makes its path visible. They do not settle down when left undisturbed. That is, colloid is quite stable. And one more thing, when colloidal solution was observed under a microscope, the colloidal particles undergo random motion in all directions over a large area. This motion of dispersed phase particles is known as Brownian motion. So Brownian motion means that's a zigzag motion of the particles. And why they are moving? Why the Brownian motion? Because they are constantly bombarded by the molecules of the dispersion medium. The components and they cannot be separated from the mixture by the process of filtration, but a special technique of separation known as centrifugation can be used to separate the colloidal particles. The components of a colloidal solution are the dispersed phase and the dispersion medium. The solute-like component or the dispersed particles in a colloid form the dispersed phase, and the component in which the dispersed phase is suspended is known as the dispersion medium. Colloids are classified according to the state, solid, liquid or gas of the dispersing medium and the dispersed phase. A few common examples are over here. Dispersed phase liquid, medium gas, aerosol, example fox cloud mist. Dispersed phase solid, medium gas, aerosol, smoke, automobile exhaust. Dispersed phase gas, dispersion medium liquid, foam, shaving cream. Dispersed phase liquid, dispersing medium also liquid, that's emulsion, milk, face cream. Dispersed phase solid, dispersing medium liquid, that's a sole, that's a milk of magnesia, mud. Next is the gas, solid, foam, rubber, sponge, pumice. Liquid, solid, gel, that's a jelly, cheese, butter. Next, dispersed phase solid, medium also solid, that's a solid sole, that is colored gemstone that crystallizes milky glass. Let us check the questions. Differentiate between homogeneous and heterogeneous mixtures with examples. As you know, homogeneous mixtures, they have uniform composition throughout the mixture. Their components cannot be separated by filtration, but separation takes place by distillation method. Examples are salt and water mixture, sugar and water mixture, etc. Heterogeneous mixture. Heterogeneous mixture, non-uniform composition throughout the mixture. That means they do not have a uniform composition throughout the mixture. Their components can be separated by the filtration method. Examples, mixture of sulfur powder and iron fillings, kerosene oil and water. Next question. How are salt, solution and suspension different from each other? So let's check out. What is salt, solution and suspension? Salt. It has dispersed phase and dispersion medium. It appears homogeneous, but it is heterogeneous. That means salt is a kind of colloidal solution. Particles are visible with the help of electron microscope. And particle size ranges from 10 to the power of minus 7 cm to the power of 10 to the power of minus 5 cm. Examples, gold, salt, gold salt, milk of magnesia, etc. Next is about the solution. It has soluble solute and solvent phase. It is homogeneous. Particles are not visible by all means. Particle size is less than 10 to the power of minus 7 cm. Example, sugar solution, salt solution, etc. Next is about the suspension. It has insoluble solute suspended in the solvent medium. It is heterogeneous. Particles are visible by naked eyes. Particle size is more than 10 to the power of minus 5 cm. Example, muddy river water, dust storm, etc. Next question. To make a saturated solution, 36 grams of sodium chloride is dissolved in 100 grams of water at 293 Kelvin. Find its concentration at this temperature. Let's check out. So here mass of sodium chloride is equal to 36 gram. Mass of water, that's a solvent, 100 grams. Mass of solution is equal to 36 plus 100, that is 136 grams. Concentration percentage is equal to 36 divided by 136 into 100, that is equal to 26.47%. That means if temperature increases, solubility increases. And if temperature decreases, solubility decreases. So let's conclude. 36 grams of sodium chloride can dissolve in 100 grams of water at 293 Kelvin and at 1 atmospheric pressure.
Mixtures are formed by a physical change only. Because of this, they are easy to separate into pure substances. The process is called purification and can be achieved by simple physical methods like dissolving, filtering, evaporating, distillation, and chromatography. Separating the components of a mixture. We have learned that most of the natural substances are not chemically pure. Different methods of separation are used to get individual components from a mixture. Separation makes it possible to study and use individual components of a mixture. Heterogeneous mixtures can be separated into their respective constituents by simple physical methods like handpicking, sieving, filtration that we use in our day-to-day life. Sometimes special techniques have to be used for the separation of the components of a mixture. So separation of mixture, how can we obtain colored component dye from blue or black ink? For this, to obtain colored component dye from ink, materials required are watch glass, ink, blue or black, beaker, burner stand. Now, let's check out the procedure. Take a beaker and fill it half with water. Take few ml of ink, blue or black, in the watch glass and place it on the mouth of the beaker. Start heating the beaker and observe. Heating is continued as long as evaporation takes place. Heating is stopped when no further change can be noticed on the watch glass. Observation. Evaporation taking place from the watch glass can be seen. Residue is left on the watch glass. So let's conclude that ink is not a pure substance, but it's a mixture of dye in water which can easily be separated by evaporation method. Ink is not a single substance. Evaporation taking from the watch glass containing ink. So what are the applications of this? This method can be used to separate the volatile component, that is the solvent, from its non-volatile solute by the method of evaporation. Another example, to obtain common salt from seawater. Seawater is trapped in small shallow pits, that's called lagoons, and is allowed to stand up for a few days. During this time, the heat of the sun evaporates water in these pits, leaving behind the solid salt. This salt is further purified by crystallization method, which we are going to study in the later part of this chapter. Next one, how can we separate cream from milk? Materials required: full cream milk, centrifuging machine, jug, test tubes. Procedure: take and boil cold milk in 2 test tubes and place these test tubes in a centrifuging machine. Centrifuge it at high speed by using a hand centrifuging machine for 2 minutes and observe. Note, there is an option. If you don't have centrifuging machine, then you can do this activity by using a milk churner used in the kitchen. So what can be observed? Cream floating on the milk can be seen. So conclusion drawn: when the milk is rotated at high speed, what happens? The suspended lighter particles, that's the fats and protein molecules, bind with each other, forming cream and skimmed milk. The cream, being lighter, floats over the skimmed milk, which can be removed easily. So what are the applications of this centrifugation method? This technique is used in washing machines to squeeze out water from wet clothes and make them dry. This technique is used in diagnostic laboratories for testing cholesterol lipids in blood ESR, that is erythrocyte sedimentation rate, and various other types of tests. It's used in dairies for separating cream from milk and butter from curd. Sometimes the solid particles in a liquid are very small and pass through a filter paper. For such particles, a filtration technique cannot be used for separation. Such mixtures are separated by centrifugation. The principle is that the denser particles are forced to the bottom and the lighter particles stay at the top when spun rapidly. Applications. Already I have taught applications. Next we will move. How can we separate a mixture of two immiscible liquid? Before that we have to learn what is meant by miscible liquid. Miscible liquid means the liquids that completely mix into each other to form a solution. They are called miscible liquids. For example, alcohol when added to water gets completely mixed. And there is partially miscible liquids also. That means a liquid which can dissolve another liquid only up to certain extent, some extent to form a solution. They are called partially miscible liquids. And for example, ethylene glycol in chloroform. Next is immiscible liquids. What are immiscible liquids? The liquids which do not mix each other, they are called immiscible liquids. For example, oil, here kerosene oil and water. Next we will learn how can we separate a mixture of two immiscible liquid. That means to separate kerosene oil from water by using a separating funnel. Materials required: separating funnel, iron stand, kerosene oil, beaker to collect here, beaker, and water. Procedure: how to do. A mixture of kerosene oil and water is taken in a separating funnel. The separating funnel is clamped on an iron stand. The mixture is allowed to stand so that it forms two distinct layers. A clean beaker is placed below and the stopcock is opened slowly so that the water falls into the beaker. Close the stopcock of the separating funnel as the oil reaches the stopcock. Observation: what we can observe. As kerosene oil being lighter, it forms the upper layer. So what we can conclude is that when a liquid mixture containing two immiscible liquids is taken in a separating funnel, then the liquid layers stand one above the other. So the liquid layer with greater density forms a lower layer, whereas the lighter liquid, which is having the lower density, it forms the upper layer. So the liquid layer with greater density, lower layer, lighter liquid with lower density, upper layer. So what are the applications of this method? They separate mixture of oil and water in the extraction of iron from its ore. Here the lighter slag is removed from the top by this method to leave the molten iron at the bottom of the furnace. Next, so the principle is that the miscible liquids separate out in layers depending on their densities. Next is about how can we separate a mixture of salt and ammonium chloride. So here the materials required are china dish, tripod stand, mixture of salt and ammonium chloride. Next is glass funnel, cotton, burner. Procedure: take the mixture of sand and ammonium chloride in a china dish. Cover the china dish with an inverted glass funnel and place it on a tripod stand. Put a loose cotton plug in the opening of the funnel so as to prevent the escape of ammonium chloride vapors. Heat the china dish on a low flame and observe. Here, what happens? Observation. White fumes, that means vapors of ammonium chloride can be seen coming out of the mixture, vapors of ammonium chloride. So these white fumes start depositing as white solid on coming in contact with the cold inner walls of the funnel, solidified ammonium chloride. Sand salt is left behind in the china dish. So what we can conclude from here: ammonium chloride being a volatile substance changes into white vapors easily, which deposits on the cold inner wall of the funnel. This ammonium chloride obtained and is called sublimation. It's called sublimate. Some other examples of solid which sublime are iodine, camphor. Next, we are going to learn about, is a dye in blacking a single color? Take a thin strip of filter paper, draw a line on it using a pencil approximately 3 cm above the lower edge. Put a small drop of ink, water soluble, that's from a sketch pen or a fountain pen, at the center of the line. Let it dry. Lower the filter paper into a jar, can be glass or beaker, test tube containing water, so that the drop of the ink on paper is just above the water level, as shown here, and leave it undisturbed. Watch carefully as the water rises upon the filter paper. Record your observations. Separation of the dyes in blacking using chromatography. What do you observe on the filter paper when the water rises on it? Do you obtain different colors on the filter paper strip? What, according to you, can be the reason for the rise of the colored spot on the filter paper? The ink that we use has water as a solvent and the dye is soluble in it. As the water rises on the filter paper, it takes along with it the dye particles. Usually, a dye is a mixture of 2 or more colors. The colored component that's more soluble in water rises faster, and in this way, the colors get separated. So this process of separation of components of a mixture is known as chromatography. Chroma in Greek means color. This technique was used for separation of colors, so this name was given. Chromatography is a technique used for separation of those solutes that dissolve in the same solvent. With the advancement in technology, newer techniques of chromatography have been developed that you are going to learn in higher classes. So what are the applications? To separate colors in a dye, pigments from natural colors, and drugs from blood. Next, we are going to learn about how can we separate a mixture of 2 miscible liquids. Here the mixture is acetone and miscible liquids are acetone and water. So the materials required are distillation flask, thermometer, condenser, beaker, iron stand. Procedure, what you have to do: take the mixture in a distillation flask, fit the flask with a thermometer, arrange the apparatus as shown here in the figure. Heat the mixture slowly, keeping a close watch at the thermometer, and observe what happens. So observation, the vapors of acetone can be seen rising up in the distillation flask with the increase in temperature. So when the temperature rises above 60 degrees Celsius, the acetone gets vaporized and forms the vapors in the flask. These vapors get condensed in the condenser and can be collected as pure liquid state from the condenser outlet. Result: acetone can be collected in the beaker from the condenser outlet, while water is left behind the distillation flask.
This method is called distillation. It is used for the separation of components of a mixture containing 2 miscible liquids that boil without decomposition and have sufficient difference in their boiling points. To separate a mixture of 2 or more miscible liquids for which the difference in boiling point is less than 25 Kelvin, fraction distillation process is used. For example, for the separation of different gases from air, different fractions from petroleum products, etc. The apparatus is similar to that for simple distillation, except that a fractionating column is fitted in between the distillation flask and the condenser. A simple fractionating column is a tube packed with glass beads. The beads provide the surface for the vapors to cool and condense repeatedly. Next, how can we obtain different gases from air? Air is a homogeneous mixture and can be separated into its components by fraction distillation. As you have learned, air is a mixture of gases and has different boiling points. And air is in a gaseous form, so it needs to be liquefied. As you have learned in chapter 1, to change matter from one state to another, we have to change either temperature or pressure or change both. So here, gaseous state to liquid state. So here what we have to do, we have to decrease the temperature and increase the pressure. So here the flow chart. Air compresses. So here when air is compressed, it becomes very hot and it is cooled by increasing pressure and decreasing temperature. So that is the liquefied air. So the liquid air allowed to warm up slowly in fractional distillation column. And what happens? Gases get separated at different heights. So here is a flow diagram, show the process of obtaining gases from air. So let us learn fractional distillation in detail. So here, let's begin stage by stage. First stage, what happens here? What we know that air need to be filtered. So here, what happens? Air is first passed through the filter to remove impurities like dust particles. So here we will get the clean air. So the filtered air is passed through compressors and it is compressed to high pressure around 200 atmospheres using the piston. The compressed air, so compressed air, that means the hot air, is passed through a freezing unit here, where here freezing cold water in. So it is passed through these pipes through freezing unit where it is cooled to about minus 200 degree Celsius. Then the cold compressed air is passed through a separator when what happens here, the carbon dioxide gas solidifies and is separated as dry ice. So the air which is now is free from carbon dioxide is forced through an expansion jet. So here there is a nozzle over here. Expansion jet, what happens? Where it liquefies. So this liquid air is allowed to slowly warm up in a fractionating column. So nitrogen, which is having the lowest boiling point, that's at minus 196 Celsius, is separated here according to the different heights. Next, argon, which boils at minus 186 degrees Celsius, is collected. Next is about the oxygen, which has higher boiling point left behind, is collected separately as liquid oxygen. So this is about the fractional distillation. There's a question over here. Arrange the gases present in air in increasing order of their boiling points. As you know, nitrogen, it has the lowest boiling point, that is minus 196 degrees Celsius. Next is the argon, which has minus 186 degrees Celsius. And the maximum boiling point, that is the oxygen, that is minus 183 degrees Celsius. Next question. Which gas forms a liquid first as the air is cool? That's the oxygen, which has a maximum boiling point, that's minus 183 degrees Celsius. Next, how can we obtain pure copper sulfate from an impure sample? To obtain crystals of pure copper sulfate salt from an impure sample by crystallization method. Materials required: impure sample of copper sulfate, beaker, china dish, glass rod. Procedure: take about 5 grams of impure sample of copper sulfate in a china dish. Dissolve it in minimum amount of water. Filter the copper sulfate solution to remove the insoluble impurities. Heat the copper sulfate solution gently on a water bath until it becomes saturated and reaches its crystallization point. Crystallization point can be checked by taking some solution on a glass rod and waving it in the air. When a solid film, the small crystals is formed on the glass rod, then further heating is stopped. This indicates that the solution has been concentrated to crystallization point. Place a china dish on the table. After covering it with a watch glass, leave it undisturbed at room temperature to cool slowly for a day and observe thereafter. Observation. Crystals of copper sulfate can be seen in the china dish along with the mother liquor. That's a residual liquid which is left after crystallization. Let us conclude. Hot and concentrated solution of any pure substance forms crystal on cooling gradually. The result: pure crystals of copper sulfate are separated from the mother liquor. So these crystals are dried further between the folds of a filter paper or on a porous plate. So the crystallization method, it is used to purify solids. For example, the salt we get from seawater can have many impurities in it. To remove these impurities, the process of crystallization is used. Crystallization is a process that separates a pure solid in the form of its crystals from a solution. Crystallization technique is better than simple evaporation technique, as some solids decompose or some, like sugar, may get charred on heating to dryness. Some impurities may remain dissolved in the solution even after filtration. On evaporation, these contaminate the solid. Applications: purification salt that we get from seawater, separation of crystals of alum, that is with carry, from impure samples. Thus, by choosing one of the above methods according to the nature of the components of a mixture, we get a pure substance. With advancement in technology, many more methods of separation techniques have been devised. In cities, drinking water is supplied from water tanks. A flow diagram of a typical water work is shown here. From this figure, write down the process involved to get the supply of drinking water to your home from the water works and discuss it in your class. So let's check out the flow diagram of a typical water works. Here is a diagram. So water from the pond, rivers, etc. contain impurities. So to remove impurities and for human consumption and other purposes, water is treated by a large number of processes. A water treatment has the following major unit: sedimentation tank, loading tank, filtration tank, and the chlorination to kill bacteria, and the pipes where it reaches the homes, factories, etc. So let's start the procedures. Water is pumped from the water reservoir, that means a source of water from ponds, rivers, lakes, etc. And this is allowed to stand in a large tank for a few hours. So what will happen? Mud, sand, and other solid particles settle down at the bottom of this tank. Next is about the loading tank. Here, the suspended particles are made to settle at the bottom by adding potash alum. So what happens when alum is added? The suspended clay particles, which has not settled down, that means very fine particles, will become heavy, and alum will deposit on clay particles and they will settle at the bottom of the tank. Next is the filtration tank. Here there are three layers: a layer of coarse gravel, and fine sand. So the water from the sedimentation tank and the loading tank is filtered through the layers of sand and gravel in the filtration tank. Next is about the chlorination. Finally, the filtered water is then treated with chlorine gas to kill the germs. And this process is known as the disinfecting the water. Now, the water is very clear from the impurities and germs. So, the clean and disinfected water is then pumped again by pumping station into high storage tanks. From high storage tanks, water is supplied to our home, factories, entire cities, where water is supplied through a network of pipes.